Alright, so hopefully when you were setting up the integral, you remember that this past weekend you watched a video that had a setup that said we're integrating from a to b, and it's always the upper function minus the lower function. And it's with respect to x. So in this case, my upper function happens to be just y equals 1. And the lower function happens to be cosine squared x. And notice that it's going from 0 to pi. So hopefully your setup was the integral from 0 to pi of 1 minus cosine squared x dx. Okay, so that's the setup. Okay, so now that we have the setup, I give you guys a hint that you are going to use a Pythagorean identity from trig. So sine squared x plus cosine squared x equals 1 can be rearranged to sine squared x equals 1 minus cosine squared x. And that helps because now this is just sine squared x. So now we have the integral from 0 to pi of sine squared x dx. And you notice that this kind of helps, but it's still hard to integrate sine squared x. You might have maybe rearranged this to sine x squared dx. This is true, but it doesn't help. Okay, this doesn't really help. Doing a u substitution won't help. So this is true, but won't help. So if you use the power reducing formula, we know that sine squared x equals 1 minus cosine of 2x over 2. And you know that if we have a binomial up top in the numerator over a common denominator, we can split them up to something like this. Okay. And then from here we can go ahead and split the integrals. I'm going to split it because if you notice, integrating 1/2 is real easy. However, integrating cosine of 2x over 2 is not too bad, but it's a u substitution because of the 2x. So I'm going to go ahead and rewrite this as, this is all equals. This is the integral 0 to pi of 1/2 dx minus the integral 0 to pi of cosine of 2x over 2 dx. Okay, if you let u equal 2x, that means du is equal to 2 dx, or dx is equal to 1/2 du. Okay. So once we go ahead and actually I can easily integrate this and say this is 1/2 x from 0 to pi. But I'm going to keep carrying it over until I integrate this. Now, the 1/2, I'm going to write it out here. This is now u. That's cosine of u. Now over 2, this can come out as a 1/2. And technically I can start computing this part, but I'm going to wait until I have it all. So I have my 1/2. This denominator of 2 can come out as a 1/2. It just has to be multiplied with that 1/2 that's already out there. And I am integrating now from 0 to pi cosine of u. Which is not bad at all. So what we have is 1/4. And now the cosine, the integral of cosine is just sine. And remember, we have a problem here. We have limits that are x values, and the function in terms of u, I'm just going to go ahead and change. I'm not going to change the limits. I'm going to change my u, my function, back in terms of x to get 1/2 x from 0 to pi. Sine x is 2x. Sine of u is just sine of 2x. Okay, and we just plug in 1/2 of pi so now I'm applying the fundamental theorem of calculus. 1/4. Now I have sine of 2 times pi, which is going to be 2 pi, minus sine of 2 times 0, which is just going to be 0. So what we have is pi over 2 minus 0 minus 1/4 times, this is going to be sine of 2 pi. What's sine of 2 pi? That should be 0. Sine of 2 times 0, that's sine of 0. Well, this is all 0. And I'm doing extra work on purpose so you guys can see that all of this is just going to be, this is going to be 0. The answer is just pi over 2. Okay, and that's how you do problem number 1 on page 402.